Hi, my name is Piotr Gejgalis and welcome to the part 1 of Tech Talk series about MobX in React. In the first meeting I will cover the basics, what MobX is, how MobX works, how to use MobX outside of the React components, and then I will look how to integrate with React components. So what MobX is? Basically, this is very simple and scalable state management. Similar to the competitors, anything that could be derived from application state should be. In MobX, most of the cases it will be automatically. MobX doesn't require a lot of boilerplate. It gives us effortless optimal rendering. In most of the cases we don't need to think about the performance. It gives us also architectural freedom, so we can use the patterns, tools by yourself, how to build the application. It's also framework agnostic. You can use it with React Native, Vue.js, Angular. It was also used to build UI in the game Battlefield, so even outside of web development. And the main reason that I use this tool daily is the statement, half the code, twice the fun, because it's a really magic tool and I like work with that. Alright, so let's dive how MobX works. It allows to observe changes in the JavaScript objects. MobX precisely notifies subscribers about the changes. MobX is functional reactive programming library, but it has a letter T, which means transparent functional reactive programming, which means that we don't need to subscribe precisely to some particular changes, but we can just use the MobX state and MobX automatically subscribes for us what is required. It tracks subscribers' access to object properties, and all above the steps work asynchronously. MobX allows to mutate the state through actions by default or directly, but this requires to change global configuration. And it's very hard to explain how it works using just some pictures, statements, and descriptions. For me, it's easier to demonstrate in the practice how it works. So let me show the real code. In the demo part, I will use application generated by Create React App tool. So you can see the development server run on port 3000, and each of the slide is just React component, which also imports the code that you can see on the right side. And in the browser console we can see the code which was executed here on the right side. In the first demo I will try to present autorun and Observable, which are tools imported directly from the MobX npm package. In this demo I will create the object friend with first name Ross, last name Geller, and also getter full name, which concatenates the first name and last name using the space. Then I will use MobX Observable function, where I can put friend as an argument, so we have observable friend instance. And in the autorun function from the MobX, I can pass as an argument the callback function, which just prints on the console autorun and observable friend dot first name. Both objects like friend and observable friend I will expose in the global scope of the browser, so we can use it in console. So when I write friend, we can see that this is a very basic object with first name, last name, and the full name is getter, so I have to click to show the name. And what is observable friend? So we can see that this is not simple basic JavaScript object. Now it's a proxy where the target is an object with getter first name, getter last name, also getter full name. We have also setters configured there, so it looks like this is more complicated structure than basic JavaScript object. Let's see what will happen if we change first name on the plain JavaScript object. So nothing happened. We just have Chandler result of this statement. And what will happen if we change first name on the observable friend object? So now we have warning from the MobX that we shouldn't mutate the state directly, but it was just a warning. We as developers, we don't care warnings. And autorun detected that the first name of observable friend has changed and the callback has been executed. So we can see autorun Chandler on the console log from here. So this is the main difference between plain object and special objects wrapped by observable wrapper from the MobX package. Okay, now let's configure MobX to not warn us about direct mutation of the state. And let me change the last name of the observable friend. So nothing happened. The autorun callback was not executed. And if we change first name to full name to be observed, when I save it, now we can see the first run, which prints the Rosgoler. And what will happen if I change the last name now? Now the autorun has been executed, so we have Rosbing. So it looks like MobX was very smart, because we were trying to print full name from the observable friend, and this full name depends on first name and last name, and it was enough to just change the last name to trigger autorun callback. All right, let me make more console logs on directly after autorun. And what we have here, so the first Rosgoler was executed directly after autorun was declared. Then we can see letter A, which is from here. Then when we try to change first name to Chandler, we see directly autorun Chandler Geller. Then we can see letter B. Then when we change the last name to Bing, we see Chandler Bing, and at the end we can see C. So it proves that autorun is triggered synchronously after we change some value in the MobX state. Okay, let me use another tool from the library. It's called run in action. I will import also from the MobX. When I save, let's see what happens. Now it's different. We see the Ross Geller from the first run of the autorun. Then we see ABC, so we can see this line, and this line. And after the C, we see Chandler Bing, so we can see both changes, first name and last name, applied to the MobX state. And then we can see the letter D after whole running action declaration. And what's that mean? It means that action in MobX gives us a transaction. So we can modify the MobX state multiple times, and the autorun, which observes some properties which were modified in this code, will be triggered only once after the whole action will end. So that's why we see ABC first, because in this action MobX doesn't trigger the autorun, and after ending action we see only one trigger. Alright, now I will add 2 lines more to run in action. I will try to revert to the initial values, I mean the Ross and the last name Geller. And when I save, let's see what happened. Wow, MobX didn't trigger autorun. He was so smart that he was able to determine that action actually didn't change the state. It was one try to change the state, but it was reverted to the original value. So this is very nice from the MobX, that it prevents us to re-render not necessary components in the React application. Alright, let me show you what is not working in MobX. When I extract this to constant observable friend, when I save it and when I want to change, it works. But when I move this constant outside of the autorun, and now when I try to change the last name, it doesn't work. Why? It doesn't work because MobX is able only to track changes for properties. So inside run of this callback, MobX is recording accesses to the properties of the objects. In this case, this access to property full name was executed before the autorun. So inside the autorun we just had simple string type. So MobX couldn't determine what kind of properties we are trying to observe. So this is gotcha from the MobX that you should be aware. All right, and let me show you next optimization from the MobX. Let me do following changes. In the full name getter, I'm trying to print get full name, and in the autorun I will try to print full name twice. Let me save this code, and we can see that first the full name getter was executed, then in autorun we have printed rows getter twice. And also when I try to get full name on the console, the get full name is still not executed. So why it was executed only once? Because MobX treated this full name as a special computed property, which is cached until its dependencies are not modified. So when I change observable friend first name to Chandler, then the getter has been executed, and we can see Chandler getter printed in the console. All right, let me bring another object to the demo. It will be settings, and let me change getter full name to be more complicated. Now in the full name we will have if statement, I'm condition. If settings show last name is trophy, then we will show first name concatenated with the last name. Otherwise we will show just the first name. By default, show last name value will be true. And let me save this code. Oh, maybe I will bring back full name only once. And when I change settings show last name to the false, now we can see that autorun has been executed, so we can see only rows. And when we change last name to Bing, now autorun has not been executed. Let me switch again to the show last name, and let me change again last name to some other property, then autorun works. Why it happens so strange? So MobX records access to the properties every time that some code runs in the autorun or computed getters, and then it will cache it until the next run is executed. So if we have conditions in the code that observes MobX states, then it will remember only dependencies from this condition. So we need to change show last name to false to switch MobX dependencies of the full name to just the first name. So this is the next MobX performance improvement to reduce re-rendering in the Redux components. All right, now let's change the full name to the method and see if that works. Yes, so if we change last name to something else, the autorun has been triggered. So it doesn't matter how complicated code is inside this autorun callback. It matters only which properties, access to which properties has been discovered during this run, and then this is the magic of the MobX. So it just records access to the properties and remembers that this autorun relies on those properties, on those objects, not even one. It can be multiple objects like settings and friend in this example. And then if those properties are changed, MobX will trigger our autorun callback again, and it repeats the logic. So again, it will record access and remembers the read properties. So we have first demo behind us. Let me go to the next one about make auto observable. I will open another example. All right. And let me refresh the page. Okay, in this example, we have again plain JavaScript object friend with full name. We have additional method setName, which sets the first name and last name properties. We have observable friend object made by known function observable, and we have new tool from MobX, make observable, where we can pass this plain object and the configuration about the properties of the object. So we want the first name and last name to be observable, the full name will be computed, and the set name will be an action. In autorun, we are printing from the plain object property full name, and also from observable friend the same full name property, and we expose it in the global scope of the browser. Okay, let me check if those objects, observable friend and friend, are equal. So they are not. If we type a friend, previously in the previous example, it was just a plain JavaScript object. Now it looks like this is something more complicated with setters and getters, and which means that make observable instrumented friend object with some tools to observe this object. If we use action setName, we can see that the friend has triggered the autorun callback, so we can see the friend has changed the name, and observable friend has old value Rosgeller, which means that those objects are completely independent. We need to change data on observable friend to have the changes. So both actions are independent, and both objects have some its life. All right, now I will try to use another function, make auto observable. I will import it also from MobX package, and I can skip the configuration object, and let me save the code. And if I change the friend to Chandler Bing, we can see it works as previously. because make auto observable has some convention that all properties in the object with simple types like string, numbers, booleans, or complex like arrays and objects will be treated as observable. All getters will be treated as computed values, and all functions or methods, like you want to name it, will be treated as actions. So you can use it to have your code base smaller. Okay, now I will try to show you the difference between observable and make auto observable. I will try to log out properties that not exist on the objects. Let me save the code, and we see that friend age is undefined and observable friend age is undefined at the beginning. And now I will add this property to observable friend, and it looks like autorun code has been triggered. It detects that there was new property added. But if I add this property to the friend, then nothing happened. It's because those functions are working differently. Make auto observable is able only to instrument existed properties with getters and setters that MobX can internally track those changes, and it's not possible in JavaScript runtime to convert friend to the proxy, but observable is creating a new proxy instance which is more powerful, which allows MobX to track even not existed properties. In the real application, we will use only make auto observable. It's not a missing feature for us, because if we have some inner object with some missing properties, this inner object will be treated in the same way as observable is treating top level properties. So I will show you that this is not necessary in real applications. All right, let's switch to the next demo. In the third demo, we will try to build some observable state. And as I said before, MobX gives us freedom to build state. So we can use factory function like here, and with some initial values passed in the arguments of the function. We can use classes. We can use also initial values in the constructor. And to use make auto observable with classes, it's enough to call make auto observable this in the constructor. And this is the preferred way that I'm using in my daily work. It also allows you to use decorators to configure which methods should be treated as actions, getters as a computed, or properties as observable properties. Then you don't need to use, you shouldn't use make auto observable, you should use make observable in the constructor. And what is the difference? Let me type rows in the console, which was created using the class, and Rachel, both are symbol MobX administration something, but the rows is instance of the class friend. If I check instance of friend, then I can see that this is a true. So having classes allows us to use instance of keyword to check what kind of type is a given object. And of course Rachel, which were created using factory function, she's not instance of friend type. Let's see how the arrays are supported by MobX. In this demo, I'm creating the friends array, which is an observable of array of items with just single property full name. And in the autorun, I'm using a map function of the friends array to display to get only full name properties, and at the end the whole array is concatenated with comma and the space. So when I refresh the page, we can see Ross Geller, Rachel Green and Joey Tribbiani in one line. And when I type friends, it looks like this is a proxy to the array of 3 proxy elements. So a lot of proxy. Let me run in action to modify only the first friend full name to Chandler Bing and see what will happen. Okay, we have the first run from autorun here, and after we made the change in the running action, we see that autorun has been executed again, and the first item is Chandler Bing, like we wanted to be changed. But now let's observe in autorun only the third item. The 2 index is the third item, I mean Joey Tribbiani, and we can see it on the console. And running action, which was trying to modify only the first item, doesn't trigger the autorun. So it looks like MobX in the previous example, when he was trying to display all friends, he was observing every object in this array, and now it relies only on the third item. So if we modify the other elements in this array, the autorun callback won't be executed. Very smart. And let me show you another utility, which is called 2JS. And I will remove this. 2JS is a utility which converts the MobX structure, which is complicated proxy with setters and getters, to the plain JavaScript objects. So it's very handy to use it to pass MobX state to other APIs, or to debugging for the console, because now we can see that it's not proxy anymore. It's very easy to read objects. Also, the MobX array wrapped by observable function is not just plain JavaScript array. It has a few extra methods. The first one is the remove. The remove method just removes item relying on its identity. So if we call it, then autorun detected that something has been removed from the array, so we can see only Ross and Joey because we removed Rachel. We have also method clear, which removes all items from the array. So now we can see empty array in the console. And also the replace method, which replaces a whole array with a new body. So we can still keep the same reference to friends array, but just to change the content of this array. Instead, we don't need to use hard to remember slice methods, so we can use some more user-friendly. All right, let's go to asynchronous actions. Let me show you demo number 5. In this demo, I will use class friendStore with properties status, which is a string, and friends, which is an array. In constructor, I will use make auto-observable this, and I will have one asynchronous action fetch friends, which in the first line changes the status to the pending. Then it will use asynchronous fetch JSON function using await, which gives us some response from the backend. And then I will try to set friends property with response from the backend, which will be an array. And then I will try to switch status to value success. And in case of any errors, I'm trying to set status to the error value. Later, I'm instantiating this store, and in the autorun, I will use 2JS to show the whole state of this store, exposing on the global scope, and that's all. In the first autorun execution, we can see friends to be empty array and status to be empty string. And let me call fetch friends, and we have first printing from autorun was from this statement, so we can see the pending status has been changed. And later we have strange situation because MobX warns us about mutating the state without the action, but of course it works. We can see that response from backend has been set, so we can see 3 items in the friends, and status is still pending. And again we have success from this line, and friends didn't change. And again the warning. Why MobX warns us about mutating the state without actions, but we have this method treated as an action because we use make auto-observable. So this is because we use asynchronous code. MobX treats modifications of the state before first usage of asynchronous code as a part of this action, but later the code executed after await is not recorded by MobX anymore, because he loses the context of this asynchronous function. Okay, so we need to go to the MobX documentation and see what they tells us how to fix it. So the first one is to wrap actions with action function, also imported from the MobX. So now we don't use async await notation anymore. We use promise API using then, and we pass here actions for success and error. And now we see that we don't have MobX warnings anymore. All right, this is not the only one solution. I don't like it because it's a lot of code, strings, and so on. The second one is to split asynchronous code to multiple actions, and in the then part we pass just handler to those methods. Let me check if that works. Yes, still no warnings. I don't like this also. It brings us more code to maintain, and remember that this name should be matched with this one only with success suffix and error suffix and so on, so I don't like it. We have next solution from the documentation, which tells us to wrap asynchronous code into running action helper. So the code after await should be wrapped, and then we can mutate the state freely. Pretty nice. Let me check. Yes, that works without warnings. And the last one, which I prefer, is using JavaScript generator functions. This star here means that this is a generator, and this is very similar to async await notation, but instead of await we use star, and instead of async we use star, and instead of await we use yield. I'm not going to dive to how JavaScript generators works, but I prefer this notation because we have as little as possible amount of the code, and it works also nicely without errors and warnings. Okay, we reached the how MobX works demo, and now it's time to integrate MobX with React. And there is a npm package named MobX React Lite, which we are using, which brings the function observer, which is a wrapper for components using MobX state. This observer wrapper uses React Memo under the hood to memorize the props, and it also re-renders components while state on tracked paths has changed. And let me show you a demo again. I will switch to the last demo. we need to install MobX and MobX React Lite in our application. Then import observer from MobX React Lite. And if we have a component which will be using the MobX state, it's required to wrap it using observer function. And now we can see the working demo of few components. Let me go through the example. We have a class friend which has 3 items in the constructor, 3 public properties. We use make auto-observable here, and it has a full name getter, set name action, nothing new from the previous examples. We have friends store, which has status and friends properties. Also getter is loading, which is truthy while status is equal to pending. In the constructor we use make auto observable, and we also use some dev tool I will present you later. We have asynchronous action fetch friends, which maps the response to be new instances of class friend. We instantiate the friend store and we put it to the global scope, and later we have friend app React component, which has 2 children. One is the friends toolbar, which we see here. This is 2 buttons. One is the fetch friends, and the second one update third friend. And also friends list, which is shown below. Let me go to the toolbar. In the toolbar we destructure the friends array. On first button click we call the fetch friends method or action. On the second one we just take the third element from the array and we directly change the first name and last name to something else. When I click we can see that it's changing. And the friends list is also wrapped by observer function. We destructure friends and is loading properties from friend store. While data is loading, we show only loading label. Otherwise, we show all friend details components, which is defined below. It's again a very simple component which has a friend prop and which uses just full name property to display this friend. All right, so let me show you the main feature of the MobX, which is reducing re-rendering as much as possible in the application. Let me refresh the page. Let me fetch the friends, and now I will start to record updating the third item. And let me show you how the React application behaves. All the components in this application were not re-rendered. Let me go deeper. Even the whole friends app didn't render it. Even Ross Geller, I mean Ross and Rachel, was not re-rendered, and only the third one Chandler Bing has been rendered. I think this situation is not possible using Redux, or maybe very hard to implement. So if it's possible using the Redux, please give some comments under this movie. But this is where the MobX shines. So we can use this feature to render a lot of data which are coming, for example, from WebSocket streaming, like stock changes or cryptocurrency. And this is why I like MobX, because I don't need to care for most of the performance issues in the React application. Okay, what if we forget to wrap the component using Observer? If we try to update the third item, then MobX will not track that it should be re-rendered. So if we switch back to use Observer wrapper, now it will work again. So many times when you are using MobX in your application and something doesn't work, doesn't change, then it means that you forget to use Observer wrapper. This wrapper is not required to use everywhere. It's required when you use MobX state in your component. So for example, the whole Friends app, which has components for toolbar and list, is not required to wrap by Observer, but here in the toolbar we need it. So, and also in the friends list, because we use some properties from friends store. Alright, in this example I'm using the global friends store, which is not really nice. I will try to make some refactoring here. I will use friends store here using memo. Okay, and I will use friends store context API. Okay, which will be type of friends store, and I will wrap the whole application with friends store context provider, and I will pass friends store as a value, and every component that will use friends store needs to use context, friends store context. All right. Oh, I will remove this one. It's not necessary. And there is somewhere friends. Okay. Missing S. All right, now it works again. And what kind of feature it brings me, that I can duplicate friends app in my slide here, so it works independently for each friends app component. I will talk more about how to use MobX when your application grows in the next parts of this Tech Talk series, so I will cover that in next chapter. Okay, let me summarize what we have learned today. MobX is a mutable state with precise change callbacks. It has computed getters which are cached based on dependencies being tracked. MobX precisely renders React components. It's enough to install MobX and MobX React Lite to integrate it with React. Makeout observable is a function which is enough to make and model your state. Observer wrapper is required to tell MobX that this React component is observing some part of the MobX state. 2JS helper is a tool which allows us to easier debug MobX structures or pass MobX structures to another APIs. And the most important, that MobX brings us a lot of fun. Thank you for watching and see you in the next episodes. Bye.